Okay, so I did the first problem and we're supposed to determine the vertical and horizontal components of the reaction at the supports. So for this particular one, we want to find AX, AY, and B. And we're given a force here, 500 pounds, and we're given a moment right here, 600 foot-pounds. That's your first step, is to draw the free body diagram. Second step is setting up the equations. You can set these up however you want. I do some of the forces in the X, then the Y, and then the moment, just so that I have the same system that I do every time, but you can do any of these equations first. And so we sum up the forces in the X direction, and that includes this AX and the X component of this force right here, which we're given the similar triangle. It's a 5, 4, 3 triangle. So I did that work over here. I found that F of X is 400, F of X is 300, and F of Y is 400. And I did those both in the positive. I did the X, the AX, and the AY in the positive direction. So we have positive AX, and then we have a plus 500 500 times this angle, which I put here, which gives us AX equals negative 300 pounds. So that just means it's going in the opposite direction of what I indicated. Sum up the forces in the Y direction. With this one, we have the AY component going in the positive direction, but we also have the B component going in the positive direction, and then we have the Y component from this force. So AY, and this force is going down, so it's going to be minus FY plus B equals 0. And I found over here, like I said, that Fy equals 400, negative 400. Since it's going down, it's in the negative direction. So AY minus 400 plus B equals 0. We have two unknowns from this equation, AY and B. So I finished that there. And then the last equation is the moment, the sum of the moments about A. So if you look at the problem, we have the AX and the AY. There's no moment here because they're right at where we're taking the moment about. So the only unknown we're going to have in this equation is B, and that's how we find that last unknown. And so we have BX and BY, we have RX and then Fy for this force, and then we have Ry and Fx, and we're neglecting the thickness of this, so there's no R in the Y direction, so that just goes to 0, plus Rx times B, so that's R in the X direction, distance from A, times B, and then we're given this moment. And so since I recognized that this was positive, the moment arm going this way, and then the moment rotating clockwise, means that that's going to be negative in my equation. So I went ahead and just put it over here as positive 600. And then, of course, this reaction is going to be clockwise. So that's why I put that in the negative direction. So it's 5 times 400. So the distance, 5 feet, times the component we get from this force. That's negative plus 10B. So that's 10 feet to this B component, times the force B equals 600. And then you just solve for B, which gives you B equals 260 pounds of force right here, force right here. And then we can plug that 260 back into this equation, which will give us AY equals 140 pounds.